Hi, Verge. We're back for another Friday.
Hey, Mark. Good to see you. Good to hear your voice, which I've heard already today.
Wow, that sounded very future ex-wife-ish. That was.
I think here's what I'm saying. Yesterday, when we welcomed each other, I was like, these people probably think we only see each other this one time. Oh no, we're prepping in the morning. We're prepping in the afternoon. We're seeing
Answering
each other a lot.
emails, texts, all kinds of stuff. All right.
Yeah.
Hi, it is Friday, and I'm Mark Corelli. I teach at Ryan High School at Denton, Texas, under normal circumstances. And this is.
I'm Verge Cornelius, and I teach at Lafayette High School in Oxford, Mississippi. And welcome to AP Live, our 8th session.
Oh, this slide again.
I'm so sick of this slide, Mark. Oh,
Hey!
that's much better. Okay. Whew, that slide was really beginning to bore me. And everybody probably got an email recently because we have exam information coming out. There's a new website that that College Board has. Can't click that link, but we did put it there.
Just tap your screen.
No. So you can find all the updates in one spot, and not just the updates as of right now, but obviously continual updates.
And that's apcoronavirusupdates.collegeboard.org, in case that's all scrunched together on a small screen for you. So.
Okay, good. And so what we did was we kind of distilled this information for AP Calculus and for pretty much BC and AB simultaneously.
The information we're going to give you,
Yeah, this is what we think is important for right now moving forward, and we'll continue to weave in other stuff as we go. But in terms of the exam, this is what we have. So May 12th is our exam date, which we didn't know that.
A week later, right?
Yeah,
so
it's a week later.
Still on a Taco Tuesday. That's good.
True, but it's at a different time. It's at 2 p.m. Eastern, which is what we are right now live, or 1 p.m. Central, which is the time zone for Mark and me.
If for some reason that date doesn't work for you, there'll be another one on June 1st at 4 p.m. But recommendations are you try that first date and save this for emergencies.
Yep. And this we kind of already knew. Online 45 minutes, probably taken at home unless your school has reopened. No multiple choice, only free response. But what we didn't know is that there's only going to be 2 questions for AP Calculus. And here's something even more interesting. The first question is going to have a 25-minute allotment, followed by 5 minutes to submit your result, whether you're submitting it by doing the typing or whether you're handwriting it out on separate paper and then taking a picture and uploading it. So they're building in 5 minutes for that. And then the second question is going to be 15 minutes, followed by another 5-minute upload. So, Mark and I are like, that doesn't really to 45.
Yeah,
but
I mean,
anyway,
I prefer doing math without numbers, but when I work with those numbers, it seems to be ending in 0.
Yeah,
so 4 5s in there.
So, I mean, this is the 45-minute window is obviously for all AP exams this year. But if you add it up for calculus, it seems like we are a little bit more than 45 minutes. So anyway, that's going to be interesting. There's going to be lots of videos. Go ahead, Mark.
Oh, I was just going to say, and they are 2 questions, but I intentionally didn't put 2 free response questions here because with this 25 minutes, probably not going to look like a traditional AP problem. Is my guess.
We don't know anything. I mean, like in terms of that, we know calculus, but nobody's telling us anything about like, it's going to be this kind of question.
But I do know the times are disproportionate.
Yeah. And one thing that I think we've alluded to, but it's going to be open notes, open textbook, and calculator allowed. So it pays to be organized and definitely get in that mode right now where you can access all your stuff quickly, look things up for yourself in your notes, in your notebook, in your textbook. And calculator allowed probably means that a calculator won't help you. You want
Yes.
to say anything else about that,
Yeah,
Mark?
the phrase that both Verge and I have heard from someone else is calculator agnostic is maybe how these are written.
Yeah.
Also, don't, just as a teacher tip, because that's who we are, don't lean on this too heavy. It's a 45-minute time test. Verge didn't say it, but once this is locked in and loaded and you start number 2, there is no going back to number 1. It is not like these are separate sections, if you want to think of it that way, from any other standardized test where you're not allowed to go back. So don't lean on that note in books. Know where things are, study with them, but you're going to have to know the stuff that you're supposed to know in order to make these useful.
Yeah, and have it like quick mental recall on certain things for sure. Yeah. And then this is especially important for students who are taking multiple AP exams, but you could use a laptop, for example, maybe for one of your AP exams, like writing your English essay, but then you might use your phone for your math exam because you're going to want to take a picture of it later, or your physics exam or something like that, or you can use the same device the whole time. I think College Board's going to give us a lot of video tutorials starting about next week, where we're going to understand a little bit better how all this is going to work. But this is what we know now, and this is good stuff. We're glad to know it.
Yeah, and just to add on to that last thing from Verge, I know that it's my understanding, and you can check at this website. We actually haven't had a chance to go to this website. We got this link about 10 minutes ago. But my understanding is you will get a chance days beforehand, if not a week or two, to get into the system and test how it's going to, whether the system will work with your interface and that type of stuff.
Practice basically, but it might not be a calculus question. It might be just, tell a story of your summer vacation or something like that. Oh, look at this. We're doing well.
Yeah,
we are doing real well.
Mr. Shea is the lucky charm, I guess.
We'll keep it. Let's hope it keeps going. We'll see.
Okay, and we've cleaned up this slide a little too. So we did our introductions and exam information. About to do our warm up. I will walk through that since it'll entail yesterday's material. And then Verge is going to take the main lead through our Unit 7 wrap-up of differential equations. She's going to work a couple free response questions for those of you, again, that don't speak in abbreviations. That's what FRQ stands for. And we have 2 items in the Dropbox already, and we really want to give an intro on one of those because Brian Passwater, who's doing the BC, he's one of the 2 people doing the BC videos at 8 a.m. Eastern, or sorry, 9 a.m. Eastern, 8 a.m. Central. He writes these worksheets, and we just kind of want to give you an intro, get you acclimated to that before we let you work on it over the weekend. So on to the warm-up. And I'm just going to read this to you. This is number 5 off of yesterday's materials. So it's adapted from 7.8, although the distractors have been changed and rearranged. And I guess I need to give you a little time to read it or go get your materials. So you can pause if you're watching us on recording or don't mind having a delay. Or I believe, Verge, do you happen to have a time kill for us during this time?
I do. So do you want to read it out loud for them first though, Mark?
Oh, sure. It says,
okay.
A dose of 400 milligrams of a drug is administered to a patient. The amount of the drug in milligrams in the person's bloodstream at time t in hours is given by A of t. The rate at which the drug leaves the bloodstream can be modeled by the differential equation dA dt equals k times A, where k is a constant. And which of the following could be an expression for A of t?
Okay,
right.
So it was this time yesterday that we got that my internet's provider started flaking out on me, and I didn't get to do my joke. So today's joke is actually yesterday's joke. So here it is. Okay, Mark.
Did you say the joke before you knew you dropped?
No.
Okay, just wondering.
What do you call dudes who love math?
Oh, I know where this is going. What do you call dudes who love math?
Algebros.
I only know, well, I probably would have guessed, but I'm really attuned to that because my 12-year-old has been doing a lot of time online gaming, and yesterday, bro was his address of the day to his friends.
Yeah,
I heard a lot of bro coming from the other room. Bro.
Okay, what do we think the answer here is, Mark?
Let's see. We've got this rate at which the drug leaves the bloodstream. That's our growth and decay differential equation. So I'm looking for a growth or decay model over here. And I'm thinking, if I can get it to come up, we're not, oh no. A is my choice. That is,
Yes,
the others all have
exactly.
sums, which really takes them out really quick, but I also see this initial condition and I have a negative growth rate because we're not growing, we have decay, right? So,
Mm-hmm. That's right.
all
Okay,
right. Virg, are
good.
you gonna
I'm
take
gonna
it
go ahead
over?
and take the screen if I
Oh, do you
can.
want me to show the PDF first, just to talk about the spacing?
No, I got it right here. I'm good.
All righty, good.
Okay. All right. So today is Friday. We've got our Unit 7 review. And I do want to give a little talking about something people emailing me about. Two days ago, I offhand said something about, 2 days ago, I said something offhand about a yellow sheet. And it's really a yellow sheet. Like, this is one of my students' yellow sheets, where I would put, as we learn things, they just add it to their yellow sheet. So this is their, for integrals, this is this particular student's yellow sheet. And it's nothing fancier than that. It's something that builds over time. It's something that I do not type up for them. They build it as we go during our entire year, really. So this is
Sorry.
just integrals. There's a separate one.
The cough was my suppressed laugh of, but
Uh,
Verge, how, if you got that student's yellow sheet, how are they going to study for the exam?
that student's actually my child. So that's, did
And
you
that's,
get that?
and knowing that, that was the suppressed.
Yeah. So anyway, with microscopic handwriting. So if you're going to handwrite, you're going to definitely need to increase your font. That's going out to all the mouse handwriting folks out there.
Yes.
All right. So what we're going to go ahead and do today, and these are in the Dropbox, but we're going to look at some differential equation free response questions that have lots of different parts dealing with the same differential equation. So this differential equation that's given, dy dx is equal to a third x and then times the quantity y minus 2 squared. This is the given information, and then every single part, A and then B and then C, go back to that given information, but have a different prompt each time. So it's a nice review of everything we've been working on since last Wednesday. Maybe not every single day, but lots of the things. All right, so in part A, it says a slope field for the given differential equation is shown below. Sketch the solution curve that passes through the point 0, 2, and then sketch the solution curve that passes through the point 1, 0. So we're going to actually sketch two different solution curves, one that goes through the point 0, 2, and here's the point 0, 2.
Sorry.
The solution curve is going to be this horizontal line. And I tend to put arrows on the end of my lines for sure, but it's not necessary. And then it also says sketch the solution curve that passes through the point 1, 0. And here's the point 1, 0.
This is the one that's going to test your skills.
Well, at least I'm drawing with a pen.
Right.
So
real live ink.
And Mark might got to go through the point, and I got to follow the curves. There's definitely some symmetry going on here.
Very nice.
Thank you. That the other solution curve that I had to draw. I'm not using two different colors here. I tend to only.
You kind of glitched out there a little bit.
Okay, I'm not using two different colors, but this is the this is this one, and then this is this one. Oopsies.
And you wouldn't have to label those on the test. The readers would look through the ones that go through the given points. So,
yeah.
Just to add a couple things before Verge scoots up and she's erasing there. On that line, please be, again, we mentioned this the other day, but we're not sure who's here every day. Solution curves can be lines. The line is the set of all points that solves that. And if you even plug 2 up into the differential equation that they give you there, you'll realize dy dx is going to equal 0 and y is 2. And the derivative of y equals 2 is 0. So that's why that one shows up as a solution, which is kind of a neat, you can confirm that one. The other one, you're really taking your best guess. But that is kind of a neat double check. And I would like to shout out to whoever took the exam in 2018. This is the 2018 release exam. I'm sure some teachers recognize it. It's available on AP Central. But shout out to whatever student was in 2018 who wrote on the test, did you really just make me draw a Speedo on my AP Calculus exam? So.
Now they can't unsee that, Mark. Thanks a lot.
No.
Okay, I'm
It
gonna
also looks like a
actually.
bird. It also looks like a bird beak. I thought a duck bill was very.
Okay, part B, and I'm going to rewrite the differential equation for us since it's now off the screen, but it says let y equals f of x be the particular solution to the given differential equation with initial condition f of 1 equals 0. So there's my, I might like to write that as an ordered pair, 1, 0. Write an equation for the line tangent to the graph of y equals f of x at x equals 1. And then use your equation to approximate f of 0.7. So I need to do two things here. I need to write the equation of the tangent line. I'm going to need a point, which I have, and a slope, which I'm going to get in just a second. And then I'm going to use that tangent line to make the approximation. So my differential equation, which is going to be my formula for the slope, is dy dx is equal to 1/3 x times y minus 2 squared. And when I substitute in 1 for x and 0 for y, so this I'm going to evaluate it at 1, 0, I end up with 1/3 times 1. Sorry. 1/3 times 1.
Oh.
Sorry. 1/3 times 1
I was
times
curious why
0
you were
minus
erasing
2.
it. That's all.
Just because I was going to crash into it. And then this slope here ends up being 1/3 times 1 times -2 squared, which is going to be 4/3. Then I'm going to write my equation still. So, and Mark and I do this a little differently if you've watched the previous videos, but I like to go ahead and use this point slope form with my y minus y1. So y minus 0 equals m, my slope, 4/3 times, in parentheses, x minus 1. There's my tangent line. And now I'm going to use it to make the approximation for the function value at 0.7. So it's going to be y is equal to 4/3 times 0.7 minus 1. Y is equal to 4/3 times 0.7 minus 1 is -3/10 or -0.3. And then when I multiply here, I end up with -12 over 30, I guess, or negative, I mean, I tend to cancel that stuff out. So -0.4 is the final result. I think Mark mentioned this the other day, when you're working for a college board, AP type stuff, we can kind of leave our final answer without simplifying. Probably a good idea.
I don't know if you want to share it, but I do have a fully robust version if you want to see it, of the unsimplified.
Nah.
Okay. Yeah, because you don't even have to simplify the slope. You could bring in that.
Oh, sure. Right. You could bring in all that stuff as your slope. That's true. But the reality is,
it's hard for me to do it, to be honest, but it's
because the reality is your professors are going to want to see -0.4. If you're
correct.
Consulting for a team of engineers, they're going to need to see -0.4, not all this other stuff. So that's really the end game, I would say. All right.
Yes.
So same differential equation, and the part C is going to ask us to find the particular solution given the initial condition of f of 1 equals 0. So this is really what we've been working on for the last couple of days, where I have dy dx is equal to 1/3 x and then times y minus 2 squared. And I'm going to use a separation of variables here to solve for y. Let's see here. So, okay, I have dy divided by y minus 2. So I'm going to get this term over to the other side, is equal to 1/3 x dx. So there's my separation step. Now I have to anti-differentiate, kind of take the integral of both sides. I tend to do whatever one seems to be easier to me first. So I probably would integrate 1/3 x dx, just reverse power rule, add 1 to your exponent, divide by that new exponent. So you get 1/3 times 1/2 x squared plus that c value. So that's really a sixth x squared plus that c value. On this side, what we really have is, you could think of it as a u substitution, where u is equal to y minus 2. I don't know, Mark, is that how you would do it, or do you just hop in that form?
I do the y minus 2 to the negative 2, and since the chain of the interior is 1, I don't worry about u du.
Okay, very good. So that's exactly right. So he's saying that he thinks about this as y minus 2 in parentheses to the negative 2, and kind of doing that reverse power rule on it,
Right,
to
because the
where
dy
he's not,
is the chain. So
yeah, he's not worried because the derivative of y minus 2 with respect to y is just 1. So u substitution is not really necessary here. So we're going to add 1 to our exponent and divide by that new exponent. So negative 2 plus 1 is going to be negative 1. So I have y minus.
surprisingly harder than it sounds sometimes.
Yes, absolutely. In fact, if it's no shame to do this on the side, are you kidding me?
Absolutely not.
You need to do, if you
are
need to do
spending
that.
money to save money on college tuition. Do what you need to do.
Yeah, all divided by negative 1, but in this case, I would probably put the negative out front. Okay, so now what? I'm going to go ahead, Mark. Yeah.
I was just saying, you said now what? So, yeah, either you can solve for y, or you can use that initial condition. I think Verge and I both are in the camp. We try to get rid of the c as soon as possible.
Yes,
so.
it just makes your algebra obstacles like lower.
Yes, I'm gonna, just because Verge hasn't used it herself, I know she has used this term in the past. It reduces the chance of malgebra before you find that c, or some mistaken algebra happens.
Plus math, yeah, algebra. Okay, so let's see here. 0 minus 2 is negative 2, and then negative 2 raised up to the negative 1 is going to be like that. Is that good, Mark?
I was getting a half, so good.
You were getting positive a half.
Yes,
yeah.
a half.
Okay,
yes.
So a half equals a sixth plus c. So when you subtract a sixth from both sides, a half minus a sixth is probably a third. I don't know. 3/6 minus 1/6.
Yes, 1/3. Yes.
So c is a third. Okay. Let's see if I can do this without losing too much paper. All right, so now come back to my other up here. I have negative, and then y minus 2 to the negative 1 is equal to 1/6 x squared, and then plus my c value, which I now know is a third. Now we got to solve for y. I would multiply everything by negative 1.
Sounds like a great plan.
Negative 1/6 x squared minus the third. And then I need to, I mean, I could do this a lot of different ways, but
yeah, there's a lot of ways to go from here.
And
as much as Verge said, on the last one, you want to get to that negative 0.4. I think on this one, you start allowing yourself to not simplify things if you're not comfortable simplifying them.
Yep. So algebraically here, what I'm doing, and this reminds me of what Mark said earlier, is that, and this is my phrase, I always say, you are only as good as your last math class. Like, you're really good at algebra and trig right now, but not as good at calculus, which is why you need to keep taking more calculus. So this stuff seems like you know what you're doing. In any case here, I've got 1 over y minus 2. I'm trying to solve for y, so I'm going to reciprocate on the other side here. So I have 1 over, all of this is in the denominator, negative 1/6 x squared minus a third. Then I'm going to add 2 to both. So I have 2 plus this crazy and I'm not going to go into too many details about why that's correct compared to what the College Board published in 2018 on their scoring guidelines. The scoring guidelines are in the Dropbox. You guys can look at those at your leisure. And also your teachers might have a Zoom with you, or some sort of a video conference with you, and talk about why that is. But that's a perfectly good presentation of that equation.
And the free response for anyone looking in the Dropbox for the scoring guidelines, they're at the end of this document. So
okay, good.
And just real quick, I know Verge didn't want to get into it, but if you just multiply the top and bottom of that ratio by -6, you'll get the scoring guideline answer.
Okay, so it's not that bad. So we have y is equal to 2 plus, now we're multiplying top and bottom here, numerator and denominator by -6. So then we get positive x squared plus 2. It looks like that, really?
And that matches the scoring guideline. Well done.
Okay. Okay, thanks, Mark. Okay. That's some good stuff.
Also, if you can, I don't know if you can pull your camera back a little, but I want to compliment you on how well organized this is, and say in the next month, if you are not an organized person, please try to make yourself organized. Help the readers find the points.
Yes, we can only give you points when we can find points. And I say we because Mark and I both read AP exams every June, and nothing's going to change this year except that we're going to do it virtually instead of going all to one meeting spot. But if we want to award points, but we can't award them if we can't find them. So please make your work legible, organized, increase your font size if need be, all that kind of stuff. The next question we're going to look at, we actually did part A and part B already. So this one was from the 2014 exam, and it says consider the differential equation dy dx equals 3 minus y in parentheses cosine of x. Let y equal f of x be the particular solution to the differential equation with the initial condition f of 0 equals 1. And then the function f is defined for all real numbers. We already did this one. I'm not going to spend time right now doing it. We just, you have to go ahead and do that solution curve. We already did this one in a previous video. Mark, I believe, led us through it, if I'm remembering correctly. And that's very similar to the last one where we have to write the equation of the tangent line. Oh, no, I didn't. Yes, I did. I did use it to approximate. So I did do things that I needed to do.
Yeah,
you did. You had -1.4
or something like that, or 2.
Yeah. Okay, so here, same thing, tangent line and use it to approximate. But here's where the real meat of the question is.
That was positive 1.4. Sorry.
Yes. Okay. So same prompt. Find y equals f of x, the particular solution to the differential equation with the initial condition f of 0 equals 1. So same idea. We're going to use that separation of variables. We're going to need to find our c value. We're going to need to use some algebra to solve for y in the end. So I'm going to recopy that dy dx is equal to 3 minus y in parentheses, and then cosine x. I need to separate, so I need to write it as dy divided by 3 minus y, and you can keep your parentheses there or not, that's your choice, is equal to cosine of x dx. And now I need to integrate. The integral of cosine x dx is going to equal positive sine x plus c. On this side right here, this is really the integral of I think of this as integral of 1 over u du, because I see, to me, this is going to turn into that natural log function. There's a little bit of something going on here, though, because the derivative of the denominator is not equal to 1. What is it equal to, Mark?
The opposite of 1.
Yeah, the opposite of 1, right? So if I said that my antiderivative here is going to be the natural log of 3 minus y in absolute value, I'd be wrong. Because if I differentiated that, I would not get this to be a positive expression. So I need that negative out front to compensate for that. Again, you can do u substitution on the side, but I think a lot of us just kind of hop and go straight to that antiderivative. Do you have anything else about that, Mark, by any chance?
No.
Okay. Also, some students, and this is your prerogative, some students prefer to see that 1 there in the numerator, so they kind of slide y to the side. Totally fine. Remember, this would be something on your yellow sheet. The integral of 1 over u du is equal to the natural log of the absolute value of u plus c. So that's kind of that general form.
Yeah. And in the form you have it written right now, it's really easy to, if you kind of do this hybrid of, I don't want to write the UDU, but I'm considering it, of going ahead and putting a negative sign on that one and throwing a negative sign out front.
I actually was just thinking about that. Like you could factor a negative out of the integral symbol and rewrite this denominator.
I do that all. No, I put the negative on the one on top.
Okay. Yeah. All those algebraic manipulations.
There's my negative 1 dy, which is my du, and so on.
Mm-hmm. Yeah, excellent. Okay, a lot of good stuff here. We're going to go ahead and substitute in this 0 for x and this 1 for y. So I have negative natural log of 3 minus 1 in absolute value is equal to the sine of 0 plus c. Sine of 0 is 0. That's a unit circle value, or, you know, however you want to think about it. Natural log of 2. So I have natural log of 2. So negative the natural log of 2 is going to be my c value. Now I can go ahead back up to this line and rewrite it. So I have negative natural log of absolute value of 3 minus y is equal to sine x minus the natural log of 2. And my calculus here is done,
Yeah.
but my algebra keeps going. I need to solve for y to really have, you know, the great answer.
Even the rich problems usually have one step that's actually calculus, right?
Yeah. So go ahead and I would multiply everything by this negative in an effort to start isolating the y. So it ends up to be negative sine. Well, I can say it, but I can't write it. Hold on a second. Negative sine x, and then plus natural log of 2. Exponentiate. And this might seem a lot clearer now than it was this time last week. E to the negative sine x plus natural log of 2. A lot of mathematicians are just going to bring that 2 out front. You don't have to. You can leave that plus natural log of 2 up in the exponent. And then here we have absolute value of 3 minus y. So then 3 minus y is equal to plus or minus 2e to the negative sine x.
How do you decide which one?
Well, let me do, can I do this? I'm going to
Sure.
go ahead and add y over here.
You can do what you need to do.
Yeah, so, I mean, basically, I'm going to do this. Okay, so I added y to both sides, which is strange, but then I, moved this term to the other side. It's still a plus or a minus. So yeah, so I don't want to box this off as my answer, not yet, because I have to think about, like, when I plug in 0 for x, which was my initial condition, when I plug in 0 for x, I need to have an output of 1. If I plug in 0 for x down here, negative the sine of 0 is going to be 0, e to the 0 is going to be 1, and then so I'm going to have 2 times 1 is 2. So do I want to say 3 plus 2 to get my output of 1, or do I want to say 3 minus 2 to get my output of 1? And Mark?
I don't think you want to add them.
Nope, you do not, which is really lovely that a lot of times people are like, oh, well, if the output's negative, then I'm going to pick the negative. Well, you got to really look at what's going on with your function before you make a decision like that. So this is a nice example of that.
Yeah, and the reason I interrupted earlier is, and this is just, again, it's just different, where different people think about it. I make the call on that plus minus right away, but it's the exact same process. I stick the 1 in on the left, I get 3 minus 1 is 2, and then I have e to the 0, so I know I need the which one do I want to have. And,
so you kind of plug it in here before you even remove the absolute value?
No, the line below.
Okay.
When I asked you how you would choose the plus minus, and so.
Okay.
But again,
okay.
But again, it doesn't matter. I would have ended up with a positive 2, but then when I solved for y, it would have been subtracted, and we end up at the same place, of course, because math works.
But yours might be a little more efficient, actually, because here you plug in a 1 for your y and a 0 for your x, and you're trying to make a true statement, is what you're saying.
Right, exactly. Just make sure it's still true.
I love it. I love it.
I do want to add, because I know there's going to be some people who do these again, which you should. When you look at the scoring guideline, both the previous problem and this one include the domain of the solution. It's listed as a note. If you look at the scoring guideline, there are no points tied to it. The domain is testable, but you don't have to make any kind of call or say what it is unless specifically asked. So don't worry about, oh, did my students not get that point a couple years ago, or do I have to really, do I have to mention the domain? And
so that's exactly right. What Mark is saying is that, like, if we don't ask for it, we don't expect you to give it to us. So like if it were asked, then I might then have to make a statement about the domain.
correct.
But that's good. Okay, so speaking about what's in the drop boxes, I think that we want to definitely take a look at Brian Passwater's activity that we put in there in addition to these free response questions and their solutions. Do you want to grab the screen, Mark?
Yeah, and I'm trying to. Let's see.
But I'm going to say that, like, so there's two files in the Dropbox. One of them has these free response questions and another free response question that I did not just work.
Yeah.
So that would be a great one to try on your own, in addition to practicing these again on your own at some point. Like, I don't just work a problem once. I work the same problem many, many times. So just to make sure that I can do it without making an error. Okay, go ahead, Mark.
I was gonna say, in that last problem, the slope field is one that gives you 6 points and you have to sketch the line segments. So just kind of bring the unit back together.
Yes. Good.
All right. So so that's one in there. It's just labeled Unit 7 wrap up free response, and the scoring guidelines are at the back. And then there's another one that's Unit 7 wrap up, and it's Big 10 is how it's labeled. And which this one actually, let's see, oh, my screen's blocking. The Big 10 is the 10 digits from 0 to 9. And these are the instructions. It says, in the box below are the numbers 0 to 9. Complete the following and cross off the number for each answer. If you complete all problems correctly, you will cross off each number exactly once. And I love his directions because if you don't do it right, you might cross off a number more than once. And I thought it was very nice of him the way he phrased that. So
and also, if you get an answer like 7.5 or -2, you've made a mistake. So exactly. It's crucial to practice correctly and be checking your work as you go. So
this is we're just going to do one of the examples. They go A through J, I believe is the 10th letter in the alphabet. And this is example D. So it says the differential equation dy dx is equal to the difference of 3 and x squared divided by y. And it has the particular solution y equals f of x with initial condition f of -1 is equal to 4. Find the slope of the tangent line to the graph of f at x equals 1. And I'll give you a chance to read that while I copy it before I switch over to my camera.
Yeah, of f at x equals -1.
And they want the tangent.
So one thing that Mark and I were discussing when we were picking this problem was, if you spend a lot of time in differential equations, which I do, I'm there, I love them, then your natural inclination is to just start separating.
Absolutely. In fact, go ahead.
Go ahead.
Sorry.
You go.
On the previously mentioned Speedo problem, we saw a lot of students that started that problem by separating the variables in A and B before they ever got to part C, and then they got to part C and they were like, oh, no. Fortunately, you won't have that problem this year because you get to take pictures. But there were a lot of arrows going, here's my problem, it's over here. So,
yeah,
because my initial reaction when I see that is, oh, I'm just going to move y over here, dx over there, cool, it's going to be a polynomial.
And I'm just going to go into that particular solution mode. But that's not what they asked you to do.
What is the tangent line?
I think they asked you just even for the slope.
Oh yeah, just slope. So
all they want is the slope of the tangent line. That's it. So it's super quick.
So let's see. X is the -1. Y is 4. Ooh, I could do that as 16 over 4, or I can be super cool and cancel a 4. So looking like 4 is my answer. So I come back out here and I cross out my 4.
Excellent.
And then you move on. And so if you get to a problem that seems a little rougher, you're having trouble with it, keep moving, because you start getting process of elimination here by knocking out some other numbers. So,
Mark, is it too much? We have about 5 minutes. Is it too much trouble to pull up that entire PDF and maybe look at another one and see? because he's got several good slope fields on there and some really good stuff.
Okay, are you seeing my PDF screen?
Mm-hmm.
Okay, so
Oh, there it is.
Whoa, and then I did that. We're just gonna keep going.
Yeah.
There we go. I
Yep.
was trying to blow it up and spun it instead. All
Okay.
right. So A is saying find B, if I read it backwards, the equation of the tangent line
Mm-hmm.
with the differential equation. B gives a slope field. So there's a really nice variety as we go through our unit.
I love C.
C's cool.
Yeah.
Find H, and then as x goes to infinity.
You definitely on C, you definitely have to separate, integrate, solve for C, solve for Y, and then find that limit. So C has a lot going on. It's a great question. I'm sure we will probably include that when we start doing our review. It's really good.
All right, and I just got a text from somebody who said the Dropbox file is different, so I may have to make a correction there. So.
Okay. It'll be correct eventually.
Within 5 minutes of being off air, I'll have it fixed. I'm sorry about that. And I guess that may put us back into, we'll have to discuss whether or not that's a start the countdown over on Monday. D, we just discussed. E, ooh.
E is very challenging, as is F.
So he's giving you a clue what G should look like, though. So.
Yep.
F is very tricky. We may talk about F on Monday.
Mm-hmm.
G is a nice multiple choice. Which of the following? And you notice they're labeled with numbers instead of letters because, again, you're trying to cross off that big 10 digit. And H.
Oh, that reminds me a lot of what we just
That's a
kind of
lot like
did.
a couple, yes.
Yeah. Oh, I has got a lot going on.
Yeah. Oh, second derivative.
Uh-huh.
Teachers will remember baby bird and potato.
And we will definitely review a lot of those topics as we get closer to the exam.
And then J has an initial condition, simply find f of 1. So find the function and then find that function at the value of x equals 1.
Yep. So these are just a set of very creative, a variety of problems. Some are challenging, extremely challenging. Some are not. Oh boy, you did it again. So anyway, great. The Big 10 should be in there, and then the free response with the answers that we worked on, and there's still another one to work on in there as well. And we wanted to put this slide here towards the end as we wrap up for the week, for the day. And that is we know a lot about our exam now. We're probably going to understand more later as we hear more from the College Board, but you should definitely be checking that website. That's what we have to do. We don't get special emails. Like, we have to check that website too. So read it, and share it with each other. If you notice that something is new, share it with your friends or whatever. Anything else, Mark?
No, I think we're good.
I want to say I heard that that in BC today they went to England or something for.
Oh yeah, shout out to Tony Record for doing a little tour of England today, and unknowingly, hello puppy.
Unknowingly, I actually brought a dog to my entire Zoom today.
Nice.
She's been snoring the whole time. I'm boring the death out of her, poor thing, but she's adorable, and I just wanted to share with everybody.
Aww.
To have a happy Friday. Tell me what the England thing was.
Oh, I was just saying, in my backdrop today is a train station in England reference.
It is a reference. This is kind of like maybe my owl or something then, right?
Yes. Yeah, you're medium regardless. All right, thanks everyone. Have a great weekend.
Great weekend. See you guys on Monday.